Hello, today I'm going to describe how to install the mcDSA-E4 controller. Now you begin the installation with a checklist, and that is you check the equipment that you have. Of course you need a controller, you need a voltage source, minimum of 30 volts of output, then you need a USB stick, and then you need a brushless motor, you need an electrical cable, you need an MPLC software, and a screwdriver, and a wire stripper. Now before you begin with the installation of the wires on the controller, you check if you have installed the MPLC software. If you haven't downloaded it from the website of MI Control, you can do it even without registering, but make sure you have registered with MI Control. There you can obtain your username and password. I'm going to show you how to do it. You click on your browser, then type in MPLC controls. Now you click on this button. So there you are, you have the MPLC software set up in a zip format. You click on it, then you can open or save it onto your disk. Now you have to check and make sure you don't have any exposed cable on your controller. If I mean exposed cable, I mean here on top. Make sure you don't have any exposed copper cable, because exposed copper cable can lead to short circuiting. Then also read your documentation very well for the two, especially for the controller and also for the motor, before you begin with the hardware installation. Then also make sure you don't attach any hardware to the motor like I have here. It is only the shaft that I have. You should be free of any attached hardware, because if the motor is attached to any hardware, you could make mistakes during the installation and therefore lead to damage or even hurt somebody. So make sure you don't have any hardware attached to your motor. Now, if you've done your work very well, you have attached all the wires very well, then you can begin with first of all turning on your voltage source. So the voltage source has been turned on. If you did your work very well, the controller should be turned on. If it's turned on, you see that the lights are burning, the LED bulbs are burning. Now, after turning on the controller, the next stage will be to search for your controller, and you begin with clicking on MC Tools. You open the MC Tools. Now it's open. After seeing this window, this is the window that you will use for installation, parameterization, and test. You click on this button, and what is being done now is you are searching for your controller. So the software has found the controller, it has identified the controller. The ID number of the controller is 1. The name of the controller is mcDSA-E4. Now, for this parameter SDO2, just ignore it for the moment. Now you have the ID number 1. So you go upwards here, you have the node ID, enter the number that you see here, in my case 1, enter upwards here, then you have the baud rate 125 kilobits, then as your communication, leave it as it is now. If it isn't like you see here, just click downwards and then choose this value. Now you click on this button to connect the controller with the motor. You see these buttons here highlighted. If they are highlighted, then you know now you have a connection. The next stage will be to click on DSA status. So I've clicked on DSA status and a window has been opened. This window, as the name implies, is the status of your controller. You see several parameters. These are your appliance information, the voltage source, the values that you have here, and yeah, it only indicates the status of your controller. Now you make a very small test to see whether your connections they are working. You see here there is a pink color. It indicates the hold to number 2. Now I will turn the shaft of the motor. If I turn the shaft, you see the colors moving from left to right. Turn the shaft to right, and also to the left, right and also to the left. So I see now that there's a connection to the motor. Now the next stage is to begin with the configuration. What you see here is the window for the configuration. What you see here checked, these are the configurations that I'd made myself. Now what you will find if you install the software for the first time is, now I'm deleting my configuration and show you the default values. So I now have all the default values here. So you begin, you check this button. Because I have a brushless motor, I check on this button. I check in this box here. Then I also check on velocity position. This is your feedback, because I'll use my Hall sensor as my feedback method. You leave these values as they are now, and then go to the next stage. Here you leave almost all the values except number of poles. So our next homework, or what we have to do, is to determine the number of poles that the motor has. In most cases, if you buy a motor from a manufacturer, you are given the number of poles that is included in the documentation. But if for one or two reasons you don't have the number of poles and you want to manually determine the number of poles, this is how you do it. And that is the theory behind it. Very simple. Every brushless motor has 3 Hall sensors. So you use these 3 Hall sensors to calculate the number of poles. So after making all these settings, I'll try and save these settings that I have made now in a controller. Now I'll go back to the status. Click on connect, go back to the status. The status window has been opened. And I want to determine the number of poles. What I do is I begin by turning the shaft clockwise of my motor. I have 24. So I have 24 turns, the position of 24 from 0 to 24, and I'll try and do it thrice in order to be sure that I have obtained the very correct value. I'll turn it again. The complete revolution is 24. 24 times 2 is 2. I'll do it for the third time. So now I have 72, and 72 divided by 3 is 24. So I have a complete turn, a revolution of 24 steps. I divide this value by the number of Hall sensors. 24 divided by 3 is 8, which means the number of poles for this motor is 8. So I go back, I connect it again, I go back to my DSA configuration and enter the value 8 here. Then I save the settings into the controller. The next stage is to determine the amount of current that you need. Now you have a default weight of 30,000 milliampere, which is about 30 ampere. Let's make it only 3 for the beginning. Let's reduce it to 3. I'm reducing it because if you use a large amount of current at the very beginning, you could cause a damage. If you have hardware, if you forget maybe to unmount the hardware that you've attached to the motor. So let's begin with a very low current, and then you can move upwards. The next stage, you click on this button, leave it as it is. Click on this button, leave it as it is. Move on, move on, move on, move on, move on, move on, move on. Then you come to this stage. Now we would like to save the settings that we have made. So I click on this button. Then I'll save my settings in this file. Now, after doing that, I save the settings again in the controller. So, now the next stage will be I would like to test my settings, whether the settings that I made, whether they are working or not. So I click on DSA controlling, click on this button, a window is opened. This is the window that I will use to test. So what I find here is my current position of 72. I don't like it, so I'll set it to 0. So I click on this button. Now the current position is set to 0. I would like to begin by only testing the number of turns, which I click on this button, and then I would like to see whether my settings worked or not. So I release it, click on this button, set it to 0 again, and then click on this button. Now you see the motor is moving in the clockwise direction. So this is a very good indication that the settings are working. So it's moving, it is moving, it is moving in the clockwise direction. The next test will be to see if we can make any position tests. Here I have the number of turns and the current position. Let me enter the number here, 10. Set the parameter to 0. Release it. Click on this button. Now it has moved 10 positions. I'll set back again to 0, and I would like to test whether the value that I use to calculate my number of poles here, right? I'll enter 24, release it again. Now you see it has turned a complete revolution. So that was right, that a complete revolution is 24 steps.